So no need to prove that root 2 is irrational for this part. Just prove that 3 root 2 is irrational. Go through the solution and see if you can do this.
Sir, completed, sir.
It's very simple, right? It's even simpler than the one which we did last class, 5 minus root 3. It's simpler than that. But the process will be very similar. Okay. So for anyone who needs help with this, I will solve it. Again, whenever we need to prove anything to be irrational, we will consider that to be rational. So let's do that. Let 3 root 2 be rational. And if that is the case, then what will happen? Then 3 root 2 can be represented in the form of a by b, where a and b are integers and b is not equal to 0. Here again, they have written not a and b are co-primes or something, but you can write it as integer or co-prime. Both of them are still same, okay? We can find that a and b are co-prime and b not equal to 0. You can write that also. Let's write the same thing, whatever is there. Co-primes and b not equal to 0. What we do after that? We just move around the variables. We leave this root 2 here, send this 3 to the other side. So it will become a by 3 times of b. And you see that a and b are integers, and there's a 3 multiplied to that. So still all of this will still be a fraction. Some integer in the numerator and some integer in the denominator. So together it will be a rational number. So your RHS is rational. So LHS should also be rational, but it is not, which is a contradiction. Okay. Okay, tell me, anyone needs help with this? I've explained the same thing again and again so many times. Anybody needs help with this? Tell me. If you need, I'll explain it again anyway. This was the simplest of all, whatever we have done so far. But the process is exactly same. Assuming this whatever to be rational, and if it is rational, we can write it in the form of a by b, where a and b are co-primes and b not equal to 0. And then here we did not even have to do any squaring, because we already know that root 2 is irrational, and 3a by b will become rational. A by 3b will become rational. So irrational number equal to rational number, that is what will give us the contradiction which we want. And why this contradiction happened? Because of our incorrect assumption that this is rational. And therefore what will happen? 3 root 2 will be proved that it is irrational. Okay, everyone is okay with this example? Quickly confirm, all of you. Give me a yes or no.
Yes, sir.
Yes, sir.
All right. Now go to the exercise. All these questions are exactly like what we have done. So finish all this right away. Only 3 questions. So I want you to finish it right away in the class itself. So prove that root 5 is irrational. Which process will be used for this kind of problem, root 5?
Sir, by squaring on both sides.
Yes, just like we used for root 2 and root 3. Same method will be used for root 5 also. So I'm just doing this for you, but you try to do this on your own, okay? If anyone needs any help or clarification, ask me, okay? This is the same as proving root 2 and root 3 is irrational. That's why I'm not saying anything. We have discussed this, but if anybody needs help, you can ask me, I'll clarify. Tell me, guys, everyone is done with this root 5?
Done, sir.
Yes, sir.
Done, sir.
Yes, sir.
Yes, sir.
Yes, sir.
I heard from Kavya, Nitya, Nitish, Pragati, Manoj,
Done, sir.
Hari, okay. Adi,
Done, sir.
okay, Charan, done.
Yes, sir.
Anushri, Vidura,
Yes, sir. Yes, sir. Done.
Yes, sir.
okay.
Sir,
Yes, tell me.
sir, I have already completed this exercise, sir.
Oh, yeah, you told me. Okay.
Sir, even I completed, sir. Yesterday, the 6 days, please.
Okay, that's good. So, what we can do now is I will give you the rest of the 2 questions as homework. Okay. Try this in your home. If you need help with any of these questions, I'll help you in the next class. But let me give you some other questions which will be slightly different. It will take me a moment. Meanwhile, if you have, you just try the second question. Okay. I'll give you a question just slightly different. Hold on for that. Okay. So let me give you that question which I was talking about. It will be slightly different from what we have seen so far. Let's take a simple example. Now, what you are seeing so far, all the examples we had seen, either it was completely one single term with irrational number, or otherwise it was irrational added with some rational number. But here you see that there are two irrational numbers added together like this. And now you have to prove that these two are, this is an irrational number. So how do you do that? And normally this will be a 3-mark question at least, okay? At least 3-mark question. So you can't just assume that root 2 and root 3 is irrational. So this needs a certain amount of proof. Anybody has any idea what we can do? Think about it.
Sir,
First
First,
square.
Yes, tell me, one of you, anyone?
sir, first add both of them, sir.
Okay. Root 2 plus root 3. How would you
Root
add them?
5.
No, you can't do that. No, no, no. Root 2 and root 3, they are irrational numbers. We cannot add irrational numbers like root 2 plus root 3 is equal to root 5. It doesn't work like that.
Sir, first squaring them and then
Okay, so what will be my first step? Tell me, what is the first step here?
root 2 plus root 3 is equal to a by b.
Yes, so we'll say let this be rational as usual. We'll assume that it is rational. So if it is rational, then root 2 plus root 3 will be equal to, we can write it as a by b, where a and b are coprimes. And b is not equal to 0. That means a and b
Now
are integers basically. Yeah, tell me.
squaring it, sir, now.
Okay, squaring both sides. Good. Tell me, what do we do after that? How do you square? This is root 2
Root plus
plus,
root 3, the whole square. A square by b square.
okay.
Now it becomes 5 equal to a square by b square. Now
No,
then the
still,
b comes
I think you
A
people are,
plus B the whole square identity.
yes, we have to use the identity. We can't just add them. Remember, just now I said root 2 plus root 3 is not root 5. Okay, only root 2 terms can be added with another root 2 term. So root 2 plus root 2 becomes 2 times of root 2. Okay, root 2 plus 5 root 2 becomes 6 root 2. Are you able to follow what I'm saying here? Root 2 behaves like a variable. Think of it like x. X plus x becomes 2 times of x, no? Same way, root 2 plus root 2 becomes 2 times of root 2. And this is 1 root 2 and 5 root 2. So 1 root 2 and 5 root 2 become 6 root 2. So root 2 term can be added with root 2, but you can't add root 2 with root 3. This is the simplest form. You have to write it like root 2 plus root 3 only. Okay, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. So yeah, so let me put this aside. Make a note of this. Whoever had confusion with this, I'm going to erase this from here. Make note of this one quickly in your note. Same way, root 3 plus 2 or 4 root 3 will become 5 root 3. So root 3 terms can be added with root 3 terms. 4 plus 1 becomes 5. Can I erase this now? Tell me.
Sir, 1 minute, 1 minute.
Yeah.
Done, sir.
Fine. So now tell me what we can do. We have assumed that root 2 plus root 3 is rational. So we can write it in the form of a by b. And we did a squaring. Up to here it is okay. What should we do next? Yeah, like Kavya was telling, we can do a plus b whole square identity. This is a, this is b. So a plus b whole square. What is the identity? What should I write?
A square plus 2AB.
A square plus 2ab or a square plus b square. Let me write it like this, and then plus 2ab. Same thing, right? So root 2 square, what is it?
2.
Yes, root 2 square becomes 2. Root 3 square
3.
becomes 3. And this becomes 2 times of root 2 into
Root
root 2.
6.
Root 6.
Yeah. Root 2 into root 3 when something is multiplied. It's an echo. Well, if you can go on mute for a second. Okay. Yeah. So when you have a multiplication, like when I said that you cannot add root 2 plus root 3, but if there is a multiplication, they can be multiplied. You can put one big whole root and you can put 2 into 3. This becomes root 6. Okay. So this also you can make note of. So root 2 into root 3 becomes root 6. Multiplication and division can be done, but not addition or subtraction with different irrational numbers. Okay, I'm going to erase this. Root 2 into root 3 becomes root 6. So I'm going to write it directly, root 2 into root 3 as root 6. Okay. See, if you go like this, there is a problem happening is this part will become rational. 2 plus 3 will become 5. Very fine. Here also you have a square and b square. This is also nicely done, and we can see that this is rational.
Yes, sir. That also I'm only getting, sir. Root 6 equal to rational numbers. A square by 2b square minus 5 by 2.
Yeah, that is what we want to. We want a contradiction.
Yes, sir.
But there is a small problem with doing like this. Because if you get to multiply a number like this, root 2 into root 3, you get a root 6 over here, which is not there. This number is not there in the question. If you get a number like this, you cannot directly assume that root 6 is irrational. You will have to prove that root 6 is irrational, going through the whole, all the steps. So unless it is a 5-mark question, it would not make sense to go and prove that root 6 is irrational. So no need to waste time with that.
Sir, we don't want to. We can keep a 2 into root 3 into root 2 only. No, sir. Why to take it as root 6, sir? If we keep it like that only, we'll get that root 3 into root 2 will be irrational, sir. Now, any irrational into irrational means.
Okay, is it irrational into irrational? Is it always irrational?
No, sir.
No, sir.
If it is only square, both are, sir. Yes, sir. But here both are different numbers, no, sir. Root 2 and root 3.
Yes, it
But
will
in
be
irrational
irrational.
number,
That is true. And
sir, but irrational number, if they both are same numbers only, if you square, will get rational. Otherwise, in all other case, it will be irrational only, no, sir.
yes, I know. See, that is true. Mathematically, like I'm telling you, of course, go on mute, guys. Yeah. So, of course, root 6 is irrational. We know that. And we will arrive at the contradiction that root 6 will be showing up as rational. So, there is no problem with that logic. The logic is absolutely right. But all the books, whatever there is for your 10th standard, they don't use this logic. So, I don't want you to do experimentation with the board exam. Okay. So, if you have to do this in the board exam, there is a small modification to this. You'll do the same logic, but with a small modification to avoid that root 6 over there. Okay. What we will do, don't square it yet over here, right? Like this itself.
So then root 3 plus root 2 into root 3 minus root 2, sir.
No. You mean to say multiplying with the conjugate?
Yes, sir.
No, that will not help us. You will still get root 2 minus root 3. No?
So if we get like that, then we can use a plus b into a minus b, no, sir.
Yeah, but only in the numerator. No? What about the denominator? It will be root 2 minus root 3. No?
Yes, sir.
So if you multiply to the numerator, you'll have to multiply to the denominator also, no? Root 2 minus root 3. We can't just multiply in the numerator. That will be, you can't change the question itself. No?
I forgot about the denominator, sir.
Yes. That's okay. Yeah, so I'm starting from the beginning again. What are we doing? Root, let it be rational. If it is rational, we can write it as a by b. Then what you do, move any one of them to the other side. Root 2 is equal to a by b minus root 3. Okay, this is how it is done in most of your books. So this is what I would like you to do in the board exam. There is no need to do any experimentation, okay? Because you never know, most of the teachers who are correcting the papers, they will just follow the normal standard from your book. So this is what I would recommend you to do, okay? But mathematically, what we were doing, that was also correct. That is also correct. There is nothing wrong with that. Yeah. So everyone is okay up to this step. What did we do? We just transposed root 3 to the other side. Now we have separated the roots. Now if you do the squaring on both sides, what will happen? This will become rational. And there will be only root 3 on this side. So which we know that it is irrational. We can assume that to be irrational. Okay. So now do the squaring.
Sir, we have to do it on both sides, right?
Squaring both sides, of course, yes.
Then
Then
root
root
3
3 would also be squared, right?
Yes, yes. It will be, but this will be a x minus y whole square, no? So you will see that. Hold on. You'll see what happens. Let's see. Let's do the squaring. So LHS becomes root 2 square, and RHS will become a by b minus root 3 whole square. Everyone okay up to this step?
Yes.
Okay. Now this becomes your a minus b whole square identity. Is it right or not?
Yes, sir.
So since a and b is already used in the question, so I'm going to use the analogy x and x minus y identity. Okay, x minus y whole square. So what is my LHS now? Root 2 square is 2, and x minus y whole square will be x square, which is x square plus y square, which is root 3 whole square, minus 2 times of x, which is a by b, into y, which is root 3. So you see root 3 has come over here now as it is. So this is the irrational part, which we want. The rest of the things will become rational. So this is 2a square by b square plus 3 minus 2a by b root 3, or 2a root 3 by b, whatever. Root 3 is in the numerator over here. Okay. Now what I want to do is I want to move this negative part to this side and 2 to this side. So it will become 3 minus 2 will become 1. Can I do that? I'm going to transpose this whole thing to the left side. So minus will become plus. It will become plus 2a root 3 by b, and this will be a square by b square plus 1. Is that right?
Yes, sir.
Okay.
Sir,
Now,
I didn't understand, sir.
okay. So up to this step was clear? This step?
Yes, sir.
So
Sir,
after,
what happened to the last three, sir? Why you have written one?
here, okay. You see, this 3 was there and there is a plus 2 this side. No, I transposed it to this side. So 2 will become minus 2, no? So 3
Okay, sir,
minus
I understand it.
3 minus 2
Understand. Two,
becomes, yeah, okay.
one.
So everyone is okay up to this step now?
Yes, sir.
All right. I heard only from few people. What about the rest of you? Is it?
Yes, sir.
Understand it, sir.
Okay, fine. So this is a square plus a square by b square plus 1. Let's simplify it further. Let it be 2a root 3 by b. This a square by b square plus 1, can I not write it as a square plus b square by b square? Don't ask me how to do this calculation. This is simple fraction addition subtraction. Anyone needs help with this? If you have 2 by 3 plus 1, how do you do addition? You multiply this 3 into 1, right? 2 plus 3 by 3. Do you know how to do that?
Yes, sir.
Okay, it's just like mixed fraction. Multiplying and adding an integer with a fraction. Just do shortcut way. Multiply 3 into 1, it will become 3 here. 2 was already here. So 2 plus 3 becomes 5. And in the denominator, of course, it will be 3 only. Whatever 3 was there, that you'll have to write. So same thing, same logic applies over here also. This b square will multiply with 1 and it will come here. And then a square plus b square by b square. Okay. If anybody has trouble with this addition, subtraction of fractions, pick up your previous old year NCERT books and practice the addition and subtraction of fractions. Okay, fine. So I'm assuming that everyone understands how to do this. Now, let's do some more transposing. B is over here, b square is over here. So if I send my b, which is in the denominator over here, I can transpose it to the numerator to the other side, right?
Yes, sir. Then,
then
b and b square gets cancelled, sir. Denominator becomes b.
Yes, of course. And this 2a will also come down. From numerator, it will go down to the denominator over here. So I'm going to do combine both the steps. So only root 3 is remaining over here on the left side. Right side, it will be a square plus b square. Let's put it inside a bracket. Because b is coming to join over here, b will be multiplied to the whole thing, no? That's why I'm putting inside a bracket. So a square in plus b square into b divided by, already a b square was there and 2a has also come down. So it will become, let me write it as 2a. Okay. Then this b will cancel one of the b and b square will become only b now. Everyone understands that? B by b square will become 1 by b only, no? B and the two b's from here will get cancelled. One of the b's will get cancelled, it will be 1 by b. Okay. So what do we have now? In the LHS, we have root 3. In the RHS, we have a square plus b square divided by, this b got cancelled, so no need to write anything else in the numerator. That's why I removed the brackets also. And here we have 2a into b. I will just write it as 2ab. Okay. Now you look at this. Your left hand side is irrational, but your right hand side is rational. Why? Because a and b are integers. So a square plus b square also will be integer, of course. If you have two integers like 3 and 5, if you do square of both of them and add, answer is also going to be some integer only, no? So numerator is an integer and then denominator also 2 times of some integer into some other integer, these two integers. Answer will also be again some integer. So integer by integer, p by q form, that's why it is rational. We have talked about this kind of form. So this is like p by q, which is rational number. Because a square plus b square is also an integer. Okay. We can say a square plus b square by 2ab is rational. Why? Because a and b are integers. And we know b is not equal to 0.
Sir, one doubt, sir.
Yes, tell me.
Sir, here we are saying only about root 3, then what about root 2?
We are not saying anything yet. Okay. See, assumption we already made with both, no? We had made our assumption that root 2 plus root 3 is rational. This is our starting point, the wrong assumption, incorrect assumption, which we say. Why is it incorrect? Because when we use this as an assumption and we did some calculation, we arrived at this contradiction. What is the contradiction here? Irrational number has become equal to a rational number, which is not possible. It's a contradiction, correct? So don't look at the root 3 only over here. This is just the point where we are doing the contradiction. At this point, any number could have been there, not just root 3.
Yes, sir.
Okay, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. So this is just the point where we are arriving at a contradiction. It could be any mathematical contradiction. Here it is irrational number becoming equal to a rational number, which is not possible. So that's what you write it in words and you say a square plus b square by 2ab is rational, whereas root 3 is irrational. Or in your own words, we can write it LHS is irrational, whereas RHS is rational. This contradiction arises due to the assumption, incorrect assumption. Hence, root 2 plus root 3 is. So, okay. Since I have written so much, I will write that also. Hold on. Okay, so this is how you will write it. You can check all that in the notes later, but just try to understand the strategy, what we did here, and for what kind of question. Why is it different? Because A and B, both of these terms, they are irrational numbers. Okay, and only difference what we did is we moved one of the numbers to the other side. Anyone you can move. You can if someone wants, they can leave the root 3 here and move the root 2 to the other side. Anyone you can do, doesn't matter. Okay, and then after that, the strategy is exactly same. Squaring both sides. Just have to be a little bit careful about calculations, what you do here. A minus b whole square identity. And then other than the irrational part, move everything to the other side. Whatever it is. In this question, it was a square plus b square by 2ab. In some other question, it may be something different, okay? But whatever it is, it will be rational. Unless it has some root terms over here. So just make sure there is no root terms over here, okay? It should not happen. So this will become irrational. This is rational. That's your contradiction. And why did it happen? Because of the incorrect assumption. What was our incorrect assumption? That this is rational. So if it was incorrect means what is the thing? Conclusion that it is irrational. Again, I'm writing rational over here. See, Pragati will find out certain information. Tell me. Irrational. Okay, happy everyone? This is irrational, not rational. All right.
Sir,
Yes, Charan, tell me.
sir, now what if one more rational number is with some that irrational number, sir, like 6 root 2 plus 5 root 3?
6 root 2 plus 5 root 3. Even if
No,
that
sir,
is,
like that if there is any number like that. If both are rational and they are having some rational number with it.
something like this.
Yes, sir.
So it will be same thing, make it equal to a by b, move any one of them to the other side.
Then here also same method we should use, sir.
Yes, same method.
Yes, sir.
Because there are two irrational numbers,
Yes,
so
sir.
you can, there is no other way. You have to move one of them.
Sir,
Yes.
what happens it will be three irrational numbers, sir?
you will not get a question like 3 irrational numbers. That will not happen.
Okay, sir.
First of all, this question itself, getting 2 rational number itself, this is itself rare. Okay, this will, in a very rare case, you will get a question like this. But you should be prepared for this. Getting
Sir, if we
3,
get 3 irrational also, we can first prove 2 of them, and then with that sum, we can prove that one more. No, sir.
yes, it can be proved. I'm not saying that it cannot be proved, of course, but it will be a very lengthy process. That's why you will not get it as a board exam question.
Yes, sir.
Okay. Yeah. So then after that, you will do squaring and all that, whatever you were doing. So after simplifying everything, you see root 3 will remain alone. Rest of the things will become rational. That will be your contradiction. Okay. So if you want, you can give a try to this also in home later. Fine. So I think we exceeded the time today. So what we can do now is quickly confirm. Anyone has any questions from what we did today? No? Okay, fine then. That's it for the maths class.